All right, so we're going to move on with the second part of 2.6. Um, doing a lot of the stuff that we did before, but we're really going to focus on this case right here when the degree of the numerator is greater than the degree of the denominator. If this is the case, then there are no horizontal asymptotes. Everything we do with vertical asymptotes are still the same, but what we have to do is actually division, and we get the slant asymptote or the end behavior asymptote, which could look like a quadratic or different problems. They look different. So again, there's no horizontal asymptote if the degree of the numerator is greater than the degree of the denominator. But we'll go ahead and divide and look at that. So everything else is still the same. You're going to be asked the same problems. I want to look at a problem here. It says find the asymptotes and intercepts of the function. Okay, so we've got x cubed over x squared minus 9. So I've got x squared minus 9, and I divide that by x to the third, or divide it into x to the third by this. Well, I'm going to set this up so I've got a 0x squared plus 0x plus 0. Just making sure I have everything accounted for here. So again, what do I do to do long division? I ask myself, what number can I multiply by x squared to get x to the third? Okay, so that would be x. So I put an x here. X times x squared is x to the third. X times minus 9 is minus 9x. So you notice there's no x squared term. So I'm just going to put a 0x squared here. So I put a change of sign, plus I've got a 9x, and then I can drop the 0 plus 0. This is my remainder, right? I can't multiply anything by x squared to get 9x. So the only answer here is this x. So it would be x plus 9x over x squared minus 9. This right here is my slant asymptote. Okay, so when I go to graph this, I'm just going to draw the asymptotes in here. I've got a slant asymptote that is, so slant asymptote is y equals x. I got that from dividing whatever my answer is. I ignore the remainder. Whatever my answer is, that is the slant asymptote. So that would have a y-intercept of 0, up 1, right 1, up 1, right 1, and it looks like this. So here's my slant asymptote. Okay, I also have, if I were to factor the denominator, right, I've also got an x plus 3, x minus 3. So I've got a vertical asymptote at -3 and at 3. So at 1, 2, 3, I've got an asymptote. And again, you won't see these when you graph this, but I'm going to graph this in Desmos and show you kind of how to look at the graph here. So we go Desmos graphing. So y equals, and that was, what was the problem? X cubed over x squared minus 9. So divide x cubed over x squared minus 9. So if you look, you got these kind of funky looking graphs here with all these different values. If I ask you to make a rough sketch, you just kind of, again, take a look at when I put these on here. I've got something that kind of runs through the middle, here, like this, something that does this and runs up along that, and then something that, down here, you'd have another one. I kind of am running out of room, but you'd have another one where you could draw like a little parabola through that thing. That would be a rough sketch of the graph. Now it asks you to find the asymptotes and the intercepts. Well, what are the intercepts? Well, if you go back to the graph, nothing's different from what we've already done. What are the intercepts? You have an x-intercept at 0, 0. You have a y-intercept at 0, 0. You can talk about all these different asymptotes. There's an asymptote right here. So all of the things that we've talked about in the first few problems are the same, except there is no horizontal asymptote. Okay, so if it asks you for the limit as x goes to positive infinity, which way is it going? Right? going to positive infinity. Negative infinity would be negative infinity. If it asks for the as x is going, the limit as x is going to -3 from the left, well, what's it doing? It's going up. If it asks for -3 to the right, same thing, it's going up. If it asks for 3 to the right, it's going down. Ask from 3 to the left, it's going down. So there's different things they could ask here, and we spent 2 days on that, so we should be good with that. Okay. So again, finding the slant asymptote, you actually got to divide. How did I know I had to do that? The numerator of the top is larger than the degree of the bottom. So the degree of the numerator is larger than the degree of the numerator. So if I take a look at, here's how they answered, or here's another example. X minus 1 over x squared minus x minus 6. We've done all these problems. So I put the answer here. Again, the numerator here, the degree of the numerator is 1, the degree of the denominator is 2. We should be able to answer all these questions. We go back into domain and range, continuity. So we should be able to answer all of these questions. If you get stuck with that, go back and look at some of your old notes. Most of these are going to be unbounded also. I know I didn't spend a ton of time on unbounded, but again, remember, if there's something that, you know, goes here, that we would say this is bounded above, if we look at that. But I don't think that should give you too much trouble. And if you get it wrong, I don't want you to stress over bounded or unbounded. But you should know how to do the rest of these and answer the rest of these questions. So if we look at this problem right here, I kind of want to go over this asymptote. See how this asymptote, there's no horizontal asymptote because we have x cubed minus 3x squared. The degree of the top is greater than the degree of the bottom. We actually have to divide this. Okay, so I've got x minus 1 outside of x cubed minus 3x squared plus 3x plus 1. So I'm going to do the division here. What number times x equals x cubed, and that would be an x squared. I'm going to put that right over here. X squared times x is x cubed. X squared times -1 is minus x squared. I'm going to change the signs, add down. So that gives me a -2x squared plus 3x. I'm going to drop that next term. X, what number times x equals -2x squared? That'd be a minus 2x. So -2x times x is minus 2x squared. -2x times -1 is a plus 2x. I'm going to change the signs. That gives me an x. And then the last one here would be a plus 1. Okay, so 1 times x, I dropped the last term as a 1, is x. 1 times -1 is -1. I change the signs, gives me a 2. Okay, so this right here is my asymptote. There's no slant asymptote, and look at how it asks you. So if you look at this, it talks about no horizontal asymptotes, but what's the end behavior asymptote? And it's graphing this right here. This, we got to remember how to graph. Okay, we got to find the vertex, plot the vertex, and you draw the rough picture of that. You can see they used a dotted line here. Okay, so I don't want to. I wanted to discuss and go over a few of those problems. I'm going to do a couple homework problems like I did before, just to make sure that you're all on the same page. But the only new thing we're doing today, everything else is something we've done. We've talked about the domain. How would I get the domain? It's all the numbers except what makes the denominator equal to 0, right? So it'd be 1, -infinity to 1, 1 to infinity. The range, look, this line here goes all the way up, all the way down. That's a y value, so it's -infinity to positive infinity. Continuity, where's the graph stop, right? We still have, at +1, we still have a vertical asymptote. So it's all x not equal to 1. What's this graph doing? It's decreasing from, again, we put down x values here, -infinity to 1. And then what's it do at 1? Well, look, it starts back up here and it's going down. So it's decreasing from 1 to whatever that point is. You'd be able to find that on Desmos. It's 2. And at 2, what's it do? It turns and starts increasing from 2 to infinity, goes up all the way. Not symmetric. Not many of these will be symmetric. It's unbounded because it goes all the way up, it goes all the way down. It has a local minimum at 3. You would be able to find that ordered pair. Remember, that's the y value. Okay, the ordered pair 2, 3, we would find that on Desmos. There's no horizontal asymptotes, but we put down the end behavior asymptote. Notice I don't call it a slant because it's not a line. And then it has a vertical asymptote at x equals 1. So all these things we've talked about, we're kind of ending this unit here, putting together things we talked about in chapter 1 and chapter 2. Okay, so that is it. I'm going to make another video of the homework, kind of talking you through it, going through it, and answering all the questions, and just making sure that we get those correct. All right. But those are the notes. You got to actually do the division to get the slant asymptote or the end behavior asymptote.